All right, today we're going to tackle a welding process that is a genuine problem solver. Flux cord arc welding, or as you probably know it, FCAW. If you've ever found yourself needing the raw speed of MIG, but the outdoor, all-weather muscle of stick welding, then this one's for you. So let's demystify this absolute powerhouse of a process. So picture this. You're out on a job and you hit that classic dilemma. You've got stick welding, which is awesome. It's tough, it can handle dirty metal, you can use it outside, but man, is it slow. Then you've got MIG, which is blazing fast and clean, but, the slightest breeze comes along and poof, there goes your shielding gas and your weld is ruined. So what do? What if you could get the best of both worlds? Well, that's exactly the gap that flux cord arc welding was designed to fill. Okay, so this chart right here, it really tells the whole story. Take a look at that productivity row. Flux cord is way up there with MIG. It is a high-deposition, fast process. Now jump down to outdoor use. It's rated excellent right alongside stick. You get the speed and the durability to work out in the elements. So what's the catch? Well, you'll see in that last row, just like stick, you've got to clean up some slag afterwards. But for so many jobs out there, that's a trade you're happy to make every single time. So what exactly is flux cord welding? Well, you've probably figured it out by now. It's this brilliant hybrid. Think of it like this. It grabs that awesome, continuous, automatically fed wire from MIG welding, which is what gives it all that speed, and it smashes it together with the protective, weld-enhancing flux that gives stick welding its incredible power and versatility.
And here's the official textbook definition. The key phrase here is tubular electrode with a flux-filled core. See, the wire isn't a solid piece of metal. It's actually a hollow tube, and it's packed with a special powder called flux. When that wire melts in the arc, the flux just comes to life. It vaporizes to create a protective shield, it cleans the weld, it can even add alloys to make it stronger. And that right there is the secret sauce to the whole process.
Now, if you've ever used a MIG welder, this whole setup is going to look incredibly familiar. You've got your power source, your wire feeder, maybe a gas cylinder sitting in the corner. Honestly, the equipment is almost identical. But the real magic, the thing that truly defines flux cord welding, isn't the machine. It's what's happening inside that tiny tubular wire.
Okay, and this brings us to a really crucial fork in the road. See, FCAW isn't just one single thing. It really comes in two main flavors, and the one you pick depends completely on where you're working and what you're building. You've got gas-shielded, which we call FCAWG, and you've got self-shielded, or FCAWS.
This slide breaks it down perfectly. Over on the left, you've got gas-shielded, FCAWG. This one uses a double shielding system. You've got the flux inside the wire, plus an external shielding gas, just like MIG. That double protection gives you incredibly clean, low-spatter welds, which is awesome for fabrication inside a shop. But on the right, you have the real field warrior. Self-shielded, FCAWS. The flux in this wire is engineered to create all the shielding you need all by itself. That means you can just ditch that heavy, clunky gas cylinder, making it the undisputed champion for outdoor construction and repair jobs.
And hey, you can literally see the difference in the tools. The gun up top is for gas-shielded. See that big copper nozzle? That's there to direct the flow of that external shielding gas over the weld puddle. But the gun on the bottom, that's for self-shielded. It's leaner, simpler. It doesn't need that big nozzle, because all the protection it needs is already being generated right from the core of the wire.
Okay, so we've pretty much established that the wire is the absolute heart of this whole process. But here's the thing. You go to pick up a spool of it, and you're faced with this string of letters and numbers. E71T-1, E71T-11, and it just looks like a secret code. Well, let's become code breakers. Let's figure out this secret language so you know exactly what you're putting in your machine.
Whoa, okay, I know this chart from the AWS handbook looks a little intense. It seems complicated at first glance, but stick with me, I promise it's actually super logical. This classification system tells a welder everything they need to know. How strong the weld will be, what positions you can weld in, and, most importantly, how it needs to be shielded. We're going to break this down piece by piece.
Let's just take a super common wire, E7121. Okay, E is easy, it just means electrode. The 7 tells us the minimum tensile strength, in this case, 70,000 psi. That next digit, the 1, tells us the welding position, and 1 is the one you want to see. It means it's an all-position wire. T, of course, stands for tubular, telling us we've got a flux cord wire. And that last part, The -1 suffix, that's the real key. It tells you everything about how the wire runs, its polarity, and its shielding gas needs. For instance, that E71T1 is a go-to gas-shielded wire for shop fabrication. But if you saw something like E71T11, you'd know right away that's a very popular self-shielded wire for working out in the field.
And just so you know, this whole system isn't just for mild steel. They use a very similar setup for other materials too, like stainless steel. The structure is pretty much the same. You get an E for electrode, numbers that tell you the specific alloy, a T for tubular, and a suffix for all the usability info. The logic holds up.
So understanding the code is one thing, and it's super important. But knowing the code is only half the battle. To really pick the right wire, you got to understand why those codes even exist. And it all comes down to what that flux on the inside is actually doing for you.
I mean, check this out. The flux is like a Swiss Army knife inside that wire. As it melts, it releases a gas to shield the arc. It forms a slag layer to protect the cooling weld. It has deoxidizers to clean out impurities, and it can even add special alloys to give the final weld specific properties, like extra strength or toughness. This is why getting the wire that matches your base metal in your job is so critical.
All right, you've done your homework, you've picked the perfect wire for the job. Now for the fun part. It's time to dial in the machine and make that thing sing. To get a really top quality weld, you have to get your parameters set just right. So let's look at the key variables you need to get under control. So here's a typical parameter chart for a gas-shielded wire. The first thing you'll notice is as you go to a thicker wire, both the wire feed speed and the current go up. That's because in this process, wire feed speed is your amperage control. You turn up the speed, you turn up the amps. It's that direct. Voltage, on the other hand, is more about controlling the arc length, which helps shape the width and flatness of your weld bead. Charts like this are the perfect place to start when you're dialing in a new machine. And here we've got a similar chart, but this one's for self-shielded wires. Now, because that flux chemistry can be so different from one self-shielded wire to another, the parameters can also change a lot. So here's the golden rule. The most important thing to remember, always check the manufacturer's specific recommendations for the wire you're using. These charts get you in the ballpark, but that data sheet from the manufacturer, that's what gets you a home run.
Okay, so let's wrap this part up with the big 4 variables you need to have locked in. First, you've got your welding current, which you control with your wire feed speed. Second is arc voltage, which shapes your bead. Third is your travel speed, how fast you move the gun, which controls the size of the weld and how much heat you're putting into the part. And finally, electrode extension, or stick out. And that last one, man, that's where the skill really comes in. Keeping that stick out consistent is absolutely critical for a stable arc and a beautiful, sound weld.
Don't just take my word for it. This quote from the AWS Welding Handbook absolutely nails it. The reason flux cord welding is getting more and more popular is simple: versatility. It is fast, it lays down strong welds, and it can go to work in places where other high-speed processes just can't. So there you have it. We've unpacked the process, we've decoded the wire, and we've gone over the parameters. You now know the fundamentals of this incredibly powerful and flexible welding process. The only question left is, now that you know the code, what are you going to build with it? Thanks for tuning in.